Hello, we are electronic engineering students at Corporación Universitaria del Meta, and this is a practicum about three-phase motor reverse rotation passing through a stop by using program logic or PLC. Let's first talk about general safety rules. First, we have to remember that children are not permitted in laboratories. We have to be aware of emergency procedures, location of emergency showers, eye washes, and emergency evacuation assembly locations. 2. Appropriate personal protective clothing must be worn at all times, like short-sleeved blouses, in laboratories and complete with instructions to students. 3. Clothing with weather at all times to be a time which will afford protection of feet, falling objects, and other potential sources of injury. Bare feet foams, sandals are prohibited. We have to remember that. 4. Fasten loose clothing and tie them. Long hurt. When using machinery, remove jewelry and rings. The possibility exists for such items to be caught in moving parts of motors. Introduction. Reversing the rotation of a three-phase motor is reflected in the chain of direction in a stirred machine, in raising or lowering of a leg, the reverse of a cart, and in a number of situations required to carry or to move a load. Using the program logic, we can achieve the realization of this task by using a schema and an assemblage, which are going to help you with more practical and easy way to live and to implement coming to solution according to our need. This is our scheme so that we have here. The objectives, talking about it first, is to understand the reverse rotation of a motor by using the PLC. And as the second part is to implement an automate system to reverse the motor rotations. Materials that we need in this case, the first one is a phase motor. It's a three-phase motor. A set of tools that we have here, the computer, 2 contactors, the PLC, the normally open push buttons, the normally closed push buttons, the light indicators, the terminal boards, and the breakers. Right. PLC, in this case, we are going to use that PLC 230. RC is a log of Siemens and is the logic controller. Before starting to talk, we need to focus first on the power supply scheme. This is the power supply scheme that we're going to use. First, to reverse rotation, this is done in the output. This is the output of the second contactor, this KM2, in which the phases are reversed. Right, I'm reversing the rotation 2 contactors. Here, physically, the 2 contactors, and here on the scheme, KM1 and KM2, they cannot be activated simultaneously, as this would generate a closed phase and a short circuit at the same time. We will use the following 3 entries or inputs. This one, I1, I2, and I3. What is I1? I1 in our scheme refers to the first start that physically is S1. I2 in our scheme is this, and physically is S6. This one is a normally closed push button, and this is the stop for our circuit. And I3, this input, in this case we have physically S2. And what is this? It's our second start. Alright, and this is our second start, is also normally open push button. Alright, we have now 2 outputs, Q2 and Q3. These are both outputs to the motor. The outputs to the motor. On leaving the stop, here, we have the gate. This is the gate that is negating the two latching relays. The relays we have here are S, they are two, and they are, we can see that these relays are connected in bridge. They are connected in bridge with the negating gate, and turn to the respective inputs. They are respectively connected to the inputs I1 and I3. The relays are connected to them. Okay. The procedure. Once implemented the program, this is the program, it's the same scheme that we have there on the board. Once implemented the program in Logo software, is the program that we are using now, for turning the inverter circuit with program logic, we transfer the program to the computer program PLC Logo. The case that we are using, the 213 RC. Alright, first we are going to activate the breakers. So we remember that we are using these breakers for the PLC and these three ones for the rest of the circuit. Alright, first we remove the port cover. We have to remove the port cover of the PLC and to connect the cable. Where the program will be transferred. Alright, and we connect the cable to the computer, right, at the USB port. Right, first, to link PLC with the computer, we have to press these two buttons. We press these two buttons, and we do OK at the same time. Alright, we have, there is a message which appear, and we say, in this case, what do we have to do? We say PC card and do OK. Appears again another message, and we choose PC card to the alright, and we do OK. What else do we have to do? We open tools. We open tools. Transferred. PC Logo. And we do OK. So we have to wait until the program loads. Alright. So in this case the program is going to be transferred. Now we expect the program to be loaded, and we come to the PLC and we do escape. Okay, we do escape. We move to start and we do then OK. Alright, so now we can use this. Let's see the inputs. First, we have our first Omega rail. The first Omega rail, and we have the terminal boards. Let's see that we have the inputs. The input I1, it goes respectively to our normally open push button. And what is this? It goes to the terminal S1 that we have here. S1, the first input goes to S1. I2, what is I2? I2 goes to the terminal S6. So we have here X6, go to the terminal S. And I3 go to the terminal S2. And I3 goes to the terminal S2. Alright? The outputs, we have our outputs. Outputs Q1 and Q2. Alright, what happened here? The output Q1, to swing, we needed to swing a sense. And so I have divided Q1, let me see, into steps. Q1 and Q2. So we have Q11, Q12, Q21, and Q22. Let's see first. Q11 goes or will face L1. Q11 will face L1. Alright. Q12 goes to A1 terminal of the contactor. Goes to the terminal of the contactor. That this is our first contactor. Alright. Now Q02. This is Q2. What happened with this? This is to swing the other way. The other rotation that we need is the same. The first one is going to face, right? And the Q2, so remember that this Q11 goes to face and Q21 goes to face. This goes to the first contactor, Kn1, and this will go to the second contactor, as we can see, the second contactor, to the terminal of the second contactor. Alright, so we have here the lines indicators. What happened with this? LS2, in this case, this contactor shows that their rotation is clockwise. Alright, and in this case, LS3 shows that their rotation is countered clockwise. Okay, to operate, in this case, I want that is a normally open push button. We start the motor. We start the motor and the turn of the rotor on the right. So it shows that it goes on the right. Alright, what happened? In this case, the indicator shows that we are doing that. On the right, as the light indicator, LS2, is showing that. For generating the left turn, alright, so that we have to change from one turn to the other, we should do I2. What is I2? I2 is the stop button. This is the stop button. In this case, a normally closed push button. And SC, in this case, again, so this is to stop. And we can initiate the next turn again with I3, that is our input S2, is a normally open push button. And so we can see that the light indicator LS3 shows that we have the other sense of the turn. To stop motor turn back, we have to push again the stop button and we stop all the circuit. This is what we have to do. Everything we have to change, so we want to change the sense of the turn of the motor. Alright, it was all. Thank you for watching.